The sky
checked.
over northern
Starting
Queensland
inspection.
was a muted grey. The early morning light diffused through a haze that
Mission
hung
sequence
low over the
confirmed. Throttle
fields
set to
and
idle.
scattered mangroves.
Fuel levels checked.
A faint
Pressure's
hum of
nominal.
distant
Ready.
engines blended with the soft rustle of palm fronds. At the small Mackay Airfield, a 4-engine Douglas DC-4 rested on the tarmac, its polished aluminum reflecting the pale dawn. Ground crews moved methodically, checking control surfaces, fuel lines, and tire pressures, their movements precise but unhurried. Inside the cockpit, the flight crew completed their pre-flight checks. Instruments clicked and whirred under their fingers. The radio crackled with routine messages from the tower. Outside, the humidity pressed against the skin, a reminder of the tropical environment in which these regional flights operated. The aircraft seemed almost poised, waiting to carry its passengers along the route that had become familiar over countless trips. Yet the stillness carried a subtle weight. The landscape beyond the airfield was deceptive. Low hills, hidden gullies, and dense patches of vegetation that could challenge even experienced pilots. Navigation in this era depended on charts, compasses, and early radio beacons, all vulnerable to misreading or error. The crew, competent and seasoned, prepared to depart, unaware that a sequence of ordinary decisions, compounded by environmental and technical factors, would lead to tragedy. As the DC-4 taxied toward the runway, engines thrumming in measured cadence, the first light of day touched the horizon. The airfield was quiet save for the mechanical symphony of piston engines, and for a moment, the scene was almost serene, routine, procedural, precise. But beneath that calm, the machinery and the men who controlled it were at the mercy of variables unseen, shifting weather patterns, the limits of early navigation systems, and the unforgiving terrain that lay beyond sight. The aircraft lifted gently into the morning sky, carrying its human and mechanical cargo toward a route that had been flown countless times before. What would unfold was not sudden. It would be the accumulation of factors, each small, each understandable, each ordinary in isolation, that together shaped the fateful chain of events remembered today as the Mackay Air Crash. In 1960, regional aviation in Australia was a lifeline across vast, often isolated territories. Mackay, a coastal town in northern Queensland, depended on air services to connect its sugarcane fields, mining districts, and scattered settlements to larger urban centers. Roads were slow and unreliable. Railways offered limited reach. The skies, though challenging, were the arteries of commerce and communication. Mackay Airways, operating small fleets of piston-engine airliners, had carved a reputation for reliability in a region defined by weather unpredictability and sparse infrastructure. The Douglas DC-4, a 4-engine, long-range piston airliner, was a workhorse of the era. Introduced during World War II, the DC-4 had transitioned into civilian use across the globe. Its rugged design, relatively simple systems, and generous payload capacity made it ideal for regional Australian routes. Yet, the aircraft relied heavily on pilot skill for navigation, especially in areas with limited radio beacons or visual references. Navigation in northern Queensland remained challenging. The region's landscape was punctuated by low mountain ranges, dense forests, and wide rivers. Tropical weather could shift rapidly. Morning fog could give way to sudden squalls, and lightning storm could materialize in minutes. Pilots depended on a combination of charts, compass bearings, and early radio aids, such as non-directional beacons, NDBs, whose signals could be distorted by terrain or atmospheric conditions. Precision was limited. A small misreading could place an aircraft off course by miles. The human element was equally critical. Crews were experienced, trained under the standards of the day, yet operating under fatigue, schedule pressure, or environmental stress could introduce errors. Procedural discipline was rigorous, but the tools available, manual checklists, limited weather forecasts, and analog instruments, demanded constant attention and judgment. Every flight was a complex interplay of aircraft capability, environmental awareness, and human decision-making. It was within this context that the flight destined for the Mackay region departed, routine in every outward sense. Yet the convergence of technical limitations, environmental conditions, and human decision-making created a scenario in which a single misalignment in the chain could escalate rapidly. The DC-4, designed to be robust and forgiving, was, in this era and terrain, only as safe as the people guiding it and the instruments they relied upon. The Douglas DC-4, in 1960, represented both strength and limitation. Its 4 radial piston engines offered reliable power, capable of sustained regional operations. The A-frame was rugged, designed to absorb rough airstrips and variable loads. However, it lacked the automation and electronic navigation aids of later generations. Altitude, heading, and airspeed management were almost entirely manual, requiring constant vigilance. An error in calculation, a misread instrument, or an over-reliance on approximated navigation could have cumulative consequences. The crew were experienced professionals. The captain had logged thousands of hours across domestic routes, familiar with Queensland's weather quirks and terrain. The first officer brought a complementary skill set, precise instrument work and disciplined checklist execution. Yet, even seasoned pilots were subject to human factors, fatigue, routine complacency, and the subtle pressures of schedule adherence. Each decision, how to intercept a beacon, when to descend, or how to adjust to crosswinds, relied on judgment honed by experience but vulnerable to distraction or misinterpretation. Environmental conditions in northern Queensland were unforgiving in subtle ways. Low-lying fog could blanket valleys, obscuring visual references. Tropical storm could form with little warning, producing wind shear, sudden rainfall, and lightning. Terrain was deceptive. Gentle-looking hills could rise abruptly into ridges and gullies, challenging pilots accustomed to more open landscapes. At 3,000 feet, an aircraft could appear above a flat plain, only to find the ground rising ahead. Understanding this environment required both technical knowledge and intimate local familiarity. Systems, too, were limiting. The DC-4 relied on barometric altimeters, magnetic compasses, and rudimentary radio navigation. Non-directional beacons, NDBs, and automatic direction finders, ADFS, were prone to signal interference. Visual flight remained essential in marginal weather. Instrument errors, misreadings, or delayed reactions could place the aircraft off its intended track. In a world before GPS, margin for error was small, and a single navigational lapse could cascade into a critical situation. The flight, in all its ordinary professionalism, existed at the intersection of these angles: mechanical reliability tempered by human fallibility, skill balance against environmental unpredictability, and systems that offered guidance but no immunity from error. Each element on its own was manageable. Together, in the precise sequence of the day, they created the conditions under which tragedy could occur. The flight had been routine up to this point. The DC-4 climbed steadily, engines humming with steady reliability. Pilots referenced charts and instruments, cross-checking bearings against limited radio signals, ensuring altitude and heading matched the planned route. Yet, the landscape was less forgiving than anticipated. Low-lying fog and scattered clouds reduced visibility, masking the gentle rise of terrain that lay ahead. As the aircraft approached the northern escarpments, subtle navigational drift placed it slightly off course. The pilots, accustomed to relying on visual references in combination with NDB signals, encountered a brief moment of disorientation. The automatic direction finder indicated a bearing that, under ideal conditions, would have aligned the aircraft with the airfield, but the tropical humidity, uneven terrain, and minor compass variation introduced cumulative error. Altitude adjustments were made according to standard procedures, yet the rising terrain demanded faster reaction than instruments and visual cues could reliably provide. The DC-4 descended gradually, following what appeared to be a safe flight path. In reality, the combination of navigational offset, limited visibility, and terrain elevation meant that the aircraft was converging with the hills below. Each second compounded the risk. Yet from the cockpit perspective, the situation remained within the expected operational envelope. The final moments were defined not by sudden mechanical failure, but by the convergence of ordinary factors. The limitations of human perception, the precision required by manual navigation, and the environment's subtle, relentless challenge. There was no dramatic struggle, no overt panic. The aircraft simply continued along its path, following the decisions and calculations that had guided it for hours. The culmination of these factors resulted in impact, a sequence measured in seconds but determined by a chain of ordinary, human-scale events over an entire flight. The accident was a product of circumstance, procedure, and environment, reminding future aviators that even routine flights demanded absolute vigilance, particularly in regions where technology could only assist, not replace, human judgment. The DC-4 had come to rest in the northern Queensland hills, a silent testament to a chain of ordinary factors converging with tragic consequence. Emergency response was immediate but constrained by the remote terrain. Rescue crews navigated rugged paths, thick vegetation, and limited access, emphasizing the logistical challenges that compounded the human toll. The investigation that followed was thorough and methodical. Aviation authorities examined every available piece of evidence: radio transmissions, flight plans, maintenance logs, and eyewitness accounts. Investigators reconstructed the flight path using last known positions, calculated drift from navigational aids, and considered environmental conditions at the time of the accident. The process was painstaking, reflecting the standards of 1960s aviation inquiry: precise, deliberate, and unemotional. Findings highlighted a combination of factors: minor navigational deviations, compounded by the limitations of barometric altitude measurement and NDB signal reliability, had placed the aircraft off its intended course. The tropical terrain, rising faster than the pilots could visually confirm in limited visibility, intersected with the descent profile. The crew's decisions, while procedurally sound, were challenged by the environment and technological limits. There was no evidence of mechanical failure. The DC-4 had performed within specifications. The impact on Mackay Airways and regional aviation was immediate. Operational procedures were reviewed, emphasizing stricter adherence to navigational cross-checks and more conservative altitude margins over rising terrain. Training protocols incorporated the lessons learned: the importance of redundancy, cross-verification of instruments, and the critical role of environmental awareness. The accident reverberated beyond the company, influencing Australian aviation authorities in updating guidance for flights in remote and challenging environments. For the local community, the crash was both shock and reminder. Families mourned the loss of passengers and crew, while regional operators faced the sobering reality that even routine flights demanded vigilance. The incident became a point of reference in aviation discourse, a case study in how human, mechanical, and environmental factors converge. Though the DC-4 had been a reliable workhorse, it could not compensate for the subtle alignment of variables that had brought it to the hills of Mackay. The 1960 Mackay Air Crash became a reference point in the ongoing evolution of aviation safety. Investigators and operators alike recognized that technology alone could not prevent accidents. The human element, judgment, attention, and adherence to procedure remained central. The tragedy highlighted the limits of early navigational aids and the need for conservative margins when operating over challenging terrain. In response, procedures across regional Australian aviation were revised. Cross-checking of radio navigation signals became standard practice. Altitudes were adjusted to provide greater buffer over rising terrain, and training incorporated simulated exercises for flights in limited visibility conditions. The DC-4, while mechanically sound, was now operated with heightened awareness of environmental hazards, emphasizing redundancy and verification at every stage of flight. The legacy extended beyond technical procedures. Communities learned to respect the fragile balance between pilot skill, aircraft capability, and environmental unpredictability. Aviation authorities documented the accident carefully, sharing insights that would influence policy and education. For future crews, the Mackay crash was a reminder: vigilance, methodical execution, and respect for the limits of both human and mechanical systems were paramount. Today, the crash is remembered quietly, not for spectacle, but for what it taught. Each policy revised, each training module updated, and each flight plan with meticulous care carries forward the lessons of that morning in northern Queensland. The sky that once bore tragic misalignment of factors now embodies caution, discipline, and the pursuit of safety. In its stillness, it reminds aviators that every flight is a product of countless decisions, each deserving the utmost attention.